Hello, my name is Eric Haddon, and I'm the Vice President of Sales and Marketing for Laval Underground Surveys. I'd like to welcome you to this presentation where we will be taking an in-depth look at our entire portfolio of borehole camera systems. Now, no presentation about borehole cameras is complete without a few moments spent discussing the history of our company. Predominantly because Laval Underground Surveys was responsible for inventing the world's first borehole camera in 1946. Claude Laval Jr. was commissioned by Peerless Pump to design a borehole camera system that could operate underwater in a deep pressure environment. Previously, operators were using impression blocks composed of either soap or wax that were lowered into the borehole, brought back to the surface, and the operators at the top had to then interpret the deformations in the impression block to attempt to decipher the condition of the borehole. Now, the first borehole camera was 9 feet long and weighed over 200 pounds, but it still represented a quantum leap forward in terms of diagnostic technology. For the first time ever, operators were able to receive relative real-time photographic data as to the condition of the borehole. With each successive decade, Laval Underground Surveys continued to lead the borehole camera industry with the introduction of new technologies. By the 1950s, we were the first company to introduce stereoscopic cameras, which allowed for a three-dimensional view of the strata within the borehole. We pushed the technological boundaries again in the 1960s by introducing the world's first borehole camera that produced live video. In the 1970s, we introduced the world's first color borehole camera, and by the 1980s, we'd introduced mirrored technology that allowed operators to view the side of the borehole. By the end of the 1980s, we would abandon this mirror technology in favor of a dedicated 360-degree rotating side view camera, first introduced on our R10 model. Coincidentally, there's still inexpensive borehole cameras that utilize mirrors to view the side of the borehole, even though this technology was rendered obsolete 30 years ago by the introduction of the R10. By the mid-1990s, we'd continued to push our borehole camera designs forward by introducing the R40. The R40 featured a more efficient design that allowed us to greatly reduce the overall size and weight of the camera. In the year 2000, we introduced the R2000, the world's first borehole camera to feature LED lighting technology. LED lighting has now become a mainstay feature for all borehole camera manufacturers. And in 2007, we introduced the camera that remains our flagship, the DC5150. The DC5150 features adjustable, high-intensity LED lights, wide-angle broadcast quality camera modules with adjustable focus, and it's capable of operating at depths up to 5,000 feet. This camera is reserved for our deep water vehicle-based applications, which we will review later in this presentation. In 2014, we introduced one of our most portable camera systems, the SC350 and 500. This system was specifically designed for customers looking for their first borehole camera system, or for those customers who need a system that's extremely portable and lightweight. In 2016, we introduced our DW1500 and 2000 systems. The DW was specifically designed to allow customers the opportunity to gain access to greater depths without the expense of designing a custom vehicle-based system. 2016 was also the year that we began domestically manufacturing our BoreSaver line of well rehabilitation chemicals, BoreSaver Ultra C and BoreSaver IKL Pro. A separate presentation is available that reviews our entire line of well rehabilitation products. In 2017, we introduced the latest version of our most popular class-leading borehole camera system, the RCam XLT. The latest iteration of the RCam features adjustable LED lighting and a new state-of-the-art DVR. While technological innovation has been a mainstay of our company since its founding, we also pride ourselves on being relentlessly focused on our customers. This spirit of innovation and customer satisfaction culminates in a philosophy that we call the Laval Difference. The Laval Difference starts with the way our company is structured. All of our processes, from design, engineering, final assembly, and sales and marketing, are all housed within a 10,000 square foot state-of-the-art manufacturing facility located in Fresno, California. This leads to a very direct line of communication within the company. If you ever have a question or concern about your borehole camera, you can call our offices and within a few moments be speaking with a knowledgeable team member who has direct access to the parties responsible for designing, testing, and assembling your camera. The Laval Difference also extends to the way we design our products. Using an ISO 9000 philosophy, every product begins as a design within SolidWorks. This allows our team of mechanical and electrical engineers to wholly refine their designs before the first piece of the system is ever assembled. Once complete, each system undergoes a rigorous testing procedure, starting with a 2-hour video burn-in period to ensure proper clarity and color representation. The system is then calibrated to ensure a depth accuracy rating of within 0.05%. Finally, our technicians perform a final system recording that will become the first part of the system's maintenance record. Whenever a system is returned to Laval for periodic maintenance, this record is updated to reflect a full and complete service history, meaning we are able to track every major service event from the beginning of the camera's service life through to the end. Every borehole camera system is then placed into a customized, single-piece box that accommodates all of the major system components and system manuals. Every system arrives ready to use and can be fully assembled within minutes. The Laval Difference applies to our service and repair departments as well. We believe that a borehole camera system loses its value if the system is spending time in a repair facility waiting to be serviced. That's why we keep 95% of the repair parts needed to fix our borehole cameras on hand. In addition, we employ a full-time staff of 5 electronic technicians to ensure that we can expedite repairs and return your camera to you in full working order. If you do ever experience an issue with your borehole camera system, help is just a phone call away. We'll start the repair process by issuing you a unique RMA number that will be specifically assigned to your service case. Once we receive your equipment, we'll perform a thorough diagnostic to generate a repair estimate, and once that estimate is approved, your repair will be conducted and the equipment returned to you. Within 2 weeks of your service event, you should expect a call from a Laval Underground Surveys representative who will collect your feedback regarding your service experience. All repairs conducted within our facility come with a 30-day repair warranty that covers all of the components replaced during the service event. New camera systems come equipped with a 1-year warranty from the date of purchase. Our commitment to the Laval Difference has allowed us to attract and retain a customer base of small and medium-sized businesses, as well as global companies and government institutions. Now I'd like to spend some time examining some of the material differences between our introductory level SC350 borehole camera and those constructed by a well-known low-cost competitor. When positioned side by side, it quickly becomes evident that there are some significant material differences in the design and construction of the SC350. For example, all of our cameras utilize robust 304 stainless steel housings, in addition to high-intensity LED lights and a wide-angle broadcast quality camera module. The body of the SC350 is designed with a durable metal frame that was specifically engineered to handle the rigors of operating in an outdoor environment. The all-metal reel contains 350 feet of double-helixed, Kevlar-reinforced coaxial cable that's wrapped in a polyurethane sheath and has a 750-pound braking strength. It's attached to a field-replaceable cable head. Now compare this to the low-cost competitor that's equipped with a non-durable plastic reel and an inexpensive frame, along with non-durable cable and a camera with low-intensity LED lights, a plastic housing, and a fisheye lens that contributes to significant distortion of the camera images. This slide highlights the image distortion to an even greater degree. The images on the left were collected from an RCam 1000 XLT utilizing the same wide-angle broadcast quality modules found across our entire line of borehole cameras. The images on the right show the distortion caused by using a fisheye lens as opposed to a wide-angle lens or a dedicated side view camera. Many fisheye lenses have been repurposed from other industries such as automotive backup cameras and were never designed to provide the definition and clarity required of a downhole application. Every borehole camera system will require periodic maintenance throughout its service life. One of the most common components that will require replacement is the cable head, the point at which the camera and the reel cable connect. Low-cost camera manufacturers require that you send in your entire system to have the camera, not the cable head, replaced. This leads to an expensive and time-consuming repair process. We've manufactured our systems to utilize cable head repair kits that enable the operator to replace his cable head without the hassle and expense of returning the system to the factory. Now we will review our entire portfolio of borehole camera systems. While many of our customers are familiar with our portable line of borehole cameras, we also manufacture vehicle or trailer-based camera systems that are designed to conduct multiple camera surveys per week. Customers have the option of selecting a number of different items, including the interior seating configuration, the operator console height, location and style of boom arm, whether it's overhead or internal, the number of monitors, the winch size and amount of cable, and whether or not the system is electrically or hydraulically powered. These systems work in conjunction with our flagship DC5150 camera, which includes adjustable LED lighting, a manually adjustable focus, and is capable of operating at depths up to 5,000 feet. The DC5150 is controlled via the CU500, which provides the video overlay, processing, and function controls for the system. This system is also combined with a solid-state DVR to provide easy transfers of your video survey data. If you'd like more information about designing your own bespoke vehicle system, please contact Laval Underground Surveys directly at info@lavalunderground.com. Next, we're going to review one of the most portable systems in our portfolio, the SC350 and 500. And you'll notice as we go through the rest of these camera systems, there are two demarcations under the model name, in this case 350 and 500. This corresponds to the amount of cable that is available on the spool. You have the option of either 350 feet or 500 feet. Now, the SC350 and 500 are extremely compact, weighing slightly over 33 pounds. They're perfectly designed for carrying the system directly out to a remote work site or a monitoring well. The system comes equipped with either 350 feet or 500 feet of cable and is driven by a manually operated winch handle that's located on the back of the reel. The SC also comes with an adjustable handbrake to hold the camera in place at a desired depth. Survey footage can be viewed via a 7-inch display monitor that is included with the system. The system also includes a video out port for connecting larger displays in the field. Paired with the SC350 and 500 is the SC166 camera, the smallest camera that we manufacture at 1.66 inches in diameter. It's ideal for boreholes between 2 to 10 inches or conditions where space is of primary concern, like operating with a pump in place. The camera features a stainless steel housing, high-intensity LED lights, and a wide-angle broadcast-quality downhole-facing camera module. Now, while the SC166 is downhole-facing only, its wide-angle lens provides high-resolution images of the side of the borehole in sizes up to 10 inches. The SC166 can also be used on our RCam or DW systems as a backup camera or for smaller applications as small as up to 2 inches. As a base system, the SC350 and 500 do not come equipped with depth counting or a recording option. We offer two optional accessories for customers who would like to unlock these features. The first is a tripod with an included sheave wheel and a high-pulse encoder. It's designed to make positioning the SC166 over the borehole significantly easier while also providing on-screen depth counting. The included encoder will take 100 measurements per revolution to ensure depth accuracy to within 0.05%. This footage mark is overlaid on the screen and can be included on survey recordings when paired with the optional DVR. The next accessory we offer for the SC350 and 500 is the touchscreen DVR monitor combination. This monitor DVR combo will replace the existing 7-inch screen with a 9-inch display that's operated using touch commands. The DVR will capture survey and video data and take still images and store them directly to a removable micro SD card that's located at the front of the unit. When paired with the tripod and the encoded sheave wheel, the survey footage will be displayed on screen and included on the survey recordings and still images. All video data is stored in an AVI format and still images are captured in a JPEG format, meaning they're readily accessible from all pervasive computer media players. The final accessory that we offer for the SC350 and 500 is the dual view adapter. In situations that call for a view of the side of the borehole that are beyond 10 inches in diameter, this accessory will allow you to connect and control an RCam dual view camera to the SC350 and 500. This accessory can be added after delivery, however, it does require an RCam camera to work. The next system is the one most closely associated with Laval Underground Surveys. Introduced 10 years ago, the RCam set the standard for portable, turnkey, affordable borehole camera systems. Consequently, there are literally thousands of RCams operating throughout the world. With the introduction of the newest iteration, the RCam 1000 and 1300 XLT, the system represents one of the best values in all of the borehole camera industry, primarily due to the inclusion of a new set of standard features. New for 2017, we've included 5 stages of adjustable LED lighting in both the side and the down view. Now, the operator has the option of selecting the level of light that's most appropriate for the conditions downhole. We've also incorporated a new highly accurate 100 pulse encoder, which takes 100 measurements per revolution and provides depth accuracy readings that are within 0.05%. We've also included a new state-of-the-art solid-state DVR that records audio, survey video footage, and still images in both internal storage and to an included removable 16GB USB stick. We will examine the new control unit in greater detail in just a moment. The RCam can be selected with either 1,000 feet or 1,300 feet of cable. As with our other portable systems, this cable is double helixed Kevlar reinforced and is equipped with a polyurethane exterior sheath. The cable is rated to a breaking strength of 750 pounds. The RCam also includes a boom arm that can be collapsed and repositioned, making it easier to transport the system. The RCam comes equipped with 8-inch pneumatic tires as standard. However, these tires can be upgraded to our 12-inch pneumatic tires if the system is going to be used in a mud or other wet or difficult terrain. The system also comes equipped with a rechargeable 12-volt battery that is capable of powering the system for several hours. In the event of a battery failure, the auxiliary clips that are included with the system can be attached to a running vehicle for supplementary power. One of the features that has made the RCam so compelling since its introduction has been the inclusion of the RCam dual view camera. This camera has an independent down view camera and an independent side view camera that rotates 360 degrees clockwise or counterclockwise depending on the commands inputted from the control console. This camera is just a little over 2 inches at about 2.25 inches in diameter and also includes the same wide-angle broadcast quality modules that are found in the rest of our camera portfolio. As you can see by the images below, they give an incredible amount of resolution and highly detailed imagery that can really make the RCam a valuable tool. The feature of the RCam that has changed the most over the last 10 years has been the control unit. This is the primary operator's console for the camera's major systems. From the control unit, the operator is able to control the speed and direction of the winch, switch between side view and down view cameras, rotate the side view camera 360 degrees clockwise or counterclockwise, adjust the LED lighting of the camera, and control the system's new solid-state DVR. The control unit also contains an auxiliary video out plug for attaching a larger viewing monitor. The new solid-state DVR has unlocked a host of new and exciting features. For the first time, operators now have the ability to add voiceover commentary to their recordings via a built-in microphone located inside the control unit. This feature is muted by default, however, it can be easily accessed via the included mini QWERTY keyboard. This keyboard also allows operators to take still images and add on-screen titles, such as the name of their business, the survey location, or other information that's pertinent to the survey recording. All survey data is recorded to an included 16GB USB stick. In the event that you do not have access to the USB stick in the field, the DVR also includes 16GB of internal video storage that allows you to record your survey data and transfer it over at a later time. The 16GB USB stick can also be upgraded to utilize a higher capacity USB drive or an external hard drive. As I mentioned earlier, all of these DVR commands are initiated through the use of an included mini QWERTY keyboard. This keyboard connects wirelessly to the RCam and is powered by a rechargeable lithium-ion battery. An included charging cable allows you to charge the keyboard while simultaneously using it with the unit in the field. All shortcut keys for the major keyboard commands can be found on the back of the keyboard. These include the commands to start, pause, and end a recording, mute or unmute the system microphone, take a still image screenshot, or add on-screen titles. From its inception, the RCam was designed as a completely turnkey camera system with all of the major components and connecting cables included with the system. In addition to the major components, the system also includes a camera carrying case for the RCam camera and a set of RCam centralizers that are a valuable tool for keeping the camera centered in a borehole and also protecting the side view glass of the RCam while in use. The RCam 1000 or 1300 is packaged in one complete container that ships on a standard size pallet and weighs roughly 240 pounds. Newly designed for 2019, Laval Underground Surveys is proud to introduce the newest member of the RCam product portfolio, the RCam TLE Level Wind. Designed to increase the versatility and portability of the RCam camera system, the RCam TLE Level Wind features a host of options not found on the standard RCam XLT winch, starting with the inclusion of a level wind. The RCam TLE's level wind has been designed to provide a higher degree of cable management that allows the operator to focus solely on conducting video surveys. The RCam TLE also features a high-resolution 100-pulse encoder that's been repositioned to vastly increase the counter accuracy and allow for a variety of in-field setups, such as the use of a tripod. To increase the level of portability of the RCam TLE, the extendable boom arm and winch handle can now be completely removed to aid in transporting, mounting, shipping, or storing the system. Additionally, a battery compartment has been added to provide a convenient storage location for the new 12-volt battery. The RCam TLE Level Wind is available as an upgrade for both new and existing RCam systems. The final system that we are going to review is our DW1500 and 2000. This system was released in 2016 and was designed for those customers who wanted to go deeper than 1,300 feet, but did not necessarily want to make the capital investment required to get a vehicle-based system designed to go down to 5,000 feet. We would consider this drawworks to be semi-portable, as it does weigh in excess of 200 pounds. However, it can be easily and conveniently mounted in the back of a pickup truck, SUV, or trailer configuration. This system does come with a built-in level wind that's designed to manage the additional 1,500 or 2,000 feet of cable and spool it evenly across the reel. It also comes with a more powerful motor than that found on the RCam. However, it is compatible with the RCam components, meaning you will utilize the same camera and control unit found on the RCam system. The winch itself can be purchased separately if you already own an existing RCam system and are simply looking for additional cable to reach greater depths. We also offer a full line of accessories for our cameras, including centralizers. This is an SC166 centralizer that can be purchased separately for your SC166 camera. It's designed to mount directly onto the body of the camera and allows it to remain centered in larger diameter holes while also preventing damage to the exterior housing of the camera. For those applications that require additional illumination, especially for older RCam systems that do not have the adjustable LED lights, the Tri-Light auxiliary lighting system is a great alternative. Designed with a stainless steel collar that mounts directly to the body of the camera and equipped with 3 military dive lights capable of going down in excess of 2,000 feet, the Tri-Light accessory is ideal for providing additional lighting in larger diameter applications. A cost-effective insurance policy against damaging the down view or side view lens of your camera is the optional lens shield accessory. Built of 316 stainless steel, this conical piece mounts at the very end of your camera and is designed to prevent damage to the down view lens and also acts as a barrier in protecting the side view lens. When used in conjunction with the included centralizers, the lens shield provides the ultimate protection when using your camera downhole. If you're looking to connect a laptop or other USB-enabled device, the USB capture device is an invaluable accessory. This will plug directly into the out port on your RCam control unit or the front of your SC350 or 500 and allow you to transmit data directly into a laptop using this one-touch device. The system comes with all of the hardware and software necessary in order to utilize the USB capture device. For those looking to bypass the included 12-volt battery with their RCam system, or for those looking for a supplementary power system to their SC350 or 500, the AC power adapter provides the ability to connect your system directly to an on-site generator. As I mentioned earlier in the presentation, one of the most common repair points is the cable head, the point where the reel and the camera physically connect. This connection will have to be replaced at some point during the service life of your camera. However, we provide an easy field serviceable part that allows you to conduct the repair yourself in as little as 2.5 hours. It takes approximately 30 minutes to solder on the new cable head connector and an additional 2 hours to allow the epoxy to fully dry and form a watertight seal. Again, this cable head repair kit prevents the time and cost associated with returning your system to the factory to have this simple part repaired. Now I'd like to spend a few moments discussing some of the common applications for borehole camera systems. When cameras were first introduced in 1946, one of the most common applications was to use the camera for fishing or identifying an object located downhole that needed to be removed. The camera provided unprecedented visual data as to the location of the object and allowed operators the opportunity to construct a tool and devise a strategy as to how best to remove the object. While use cases for cameras have expanded greatly over the years, fishing still remains one of the most popular applications. Receiving the visual data from a camera can prove to be an invaluable tool when it comes to devising your strategy for object removal. Another common application for a borehole camera system is assessing issues that are occurring downhole. Much like an impression block, without the visual confirmation of an issue occurring, like a crack or a perforation in the case, everything else is simply an educated guess as to what is actually occurring downhole. There exists a great opportunity to use your camera as a tool to show your customers the quality and efficacy of your work. For example, if you were to conduct a camera survey of a customer's well, identify and call out the issues viewed downhole, proceed correcting those issues, and then conduct a follow-up survey highlighting that the work was performed, imagine what a powerful sales tool that survey data then becomes. Now, the well owner has tangible video evidence that the issues downhole were corrected and that you have the ability to charge a greater amount because of the additional value added to the customer's experience. Borehole cameras are also used in the construction industry. The images below were collected from an RCam system that was used to inspect micropiles on a construction project in New York City. The SC350 and 500, equipped with the small diameter SC166, have proven to be invaluable tools for inspecting monitoring wells that are typically 2 inches in diameter. The small size of the SC166 and wide-angle camera module make it ideal for use in these smaller applications. Over the last several years, we've witnessed a dramatic and sustained increase in the number of borehole cameras that are being used in the practice of well rehabilitation. Operators will first conduct a downhole survey to evaluate the condition of the well and to help make a definitive diagnosis as to the nature of the problem. For example, are you dealing with an issue related to iron bacteria biofouling or a mineral incrustation issue? Without the hard visual data provided by a borehole camera, it can be incredibly difficult to tell exactly what the issue is, much less how to effectively treat the problem. With the visual data in hand, you can plan your strategy as to how to approach the rehabilitation, whether by a mechanical or chemical method, or perhaps a combination of both. Once the rehabilitation has been performed, conduct a follow-up survey to document the efficacy of the rehab and to serve as a tangible deliverable to your customer, showing that the downhole issues were resolved. This methodology has become so popular that internally we coined the term see, treat, and verify to describe the practice. Again, use the camera as an initial diagnostic tool to identify the issues occurring downhole. Perform your rehabilitation and follow up with a secondary verification survey to demonstrate the successful completion of the well rehabilitation. All of these common applications aside, we still believe that every single time a pump is pulled, you have the opportunity to use a borehole camera to evaluate the condition of the well and to serve as a preventative maintenance program for issues that may occur in the future. Now I'd like to review some key features that prospective customers should be considering when evaluating various borehole camera systems. This is an editorial that was published in the October 2006 issue of the Water Well Journal, written by editorialist Ed Butts, a frequent contributor to WWJ. And although the article is in and of itself over 10 years old, a lot of the points that he makes in this article still ring true today in terms of essential features a customer should be looking at when evaluating a borehole camera system. His first point is, buy a system with an actual side view. As I mentioned at the beginning of the presentation, we developed mirror technology in the 1980s, and by the end of that decade had moved on to independent side view cameras. There are still inexpensive camera manufacturers out there today that utilize mirrors to get a reflective view of the side of a borehole. There are also camera manufacturers out there that utilize fisheye lenses to give a distorted view of the side of a borehole. All of those are really insufficient when compared to a dedicated side view camera. Without that high fidelity, high detail imagery, the camera system really doesn't work the way it's intended. You really need that dedicated side view camera. His next point is, don't skimp on the lights. As we can all attest, lighting downhole can be a little tricky. Sometimes you have too much light due to turbidity in the water, sometimes not enough. That's why we incorporated 5 stages of adjustable LED lighting in both the side view and the down view to the RCam, ensuring that the operator always has the ability to dial in the brightness just as needed for that given application. His next point is to get a camera system that displays your depth counting on screen. Some of the less expensive systems that exist today put demarcations on the cable as their form of measuring depth. The problem with that is, as you use the camera system, eventually you will be required to do cable head repairs. And when you perform a cable head, you'll have to cut off segments of that cable in order to find good cable to rehead the camera. As you do that, that marking on the cable is going to become inaccurate as you take more and more off in order to find good cable. Now we, on the other hand, utilize real-time readings off of a high accuracy, high pulse encoder that's taking 100 measurements per revolution, ensuring that you are within 0.5% of exactly what is displayed on screen. The other advantage to having an on-screen depth counter is you have a reference point. So if you were to go down hole your first time, find a crack in the casing at a specific depth, you know specifically, based on the overlay that's shown on screen, where that crack was. Then on subsequent surveys, you can easily lower the camera back into the hole, go exactly to that depth count, and evaluate the issue that you spotted on your previous survey. The next point he makes is to make sure you get a system with a decent recorder. Now, of all of the technological elements of a downhole camera system, the element that's going to change the most quickly is going to be your recorder. When we first introduced the RCam 1000, we used VHS tapes. Then we evolved to using DVD burners. Now we're using solid-state DVRs that export directly to USB sticks. Be thinking about a camera system that's going to evolve with you, that you can work with into the future. And really what that means is partner with a company that's going to make the investment in future-proofing their technology. While today it may be USB sticks, in the future we may be able to beam that footage directly to the cloud. But if you're working with a small company that's not investing in the research and development process, they'll probably not have those options available for you to utilize or upgrade to into the future. His last point is buy a 1,000-foot system. Now, Ed doesn't literally mean buy a system with 1,000 feet. What he really means is this camera system ideally will become such a valuable part of your business that ultimately you'll be using it more than you think. While today you may only go down to depths of 500 feet, 5-7 years from now, you may be doing jobs with the camera that require 1,000 feet of cable. If you look at all of the componentry involved in a camera system, the cable is actually the least expensive part, meaning it's also the least expensive to go ahead and add more to. It's very, very difficult to add more cable after the fact, but when you're first evaluating a camera system, if you buy more than you think you need, you'll be future-proofing that camera system and allowing yourself the opportunity to exploit greater jobs and greater depths far into the future. Next, I'd like to review some common qualifying questions that we encourage prospective customers to think about when they're evaluating borehole camera systems. The first is, what is the level of technical complexity involved in operating the system? I think in a lot of instances, there are intimidation factors that are associated with using a downhole camera system because there are a lot of things that are more akin to a computer than they are any other type of equipment you might find in the drilling industry. As such, there's a certain level of intimidation in terms of using that piece of equipment or understanding it, getting hands-on. The reality is, most downhole camera systems are composed of 3 distinct elements. There's the winch control, the directions forward and backward, the camera rotation controls, 360 degrees clockwise or counterclockwise, and the DVR. If you're willing to learn and operate these 3 separate systems, the reality is a downhole camera system can be incredibly easy to use and incredibly easy to operate in the field. The next question we like to have a customer consider is, in the event that something goes wrong, how quickly can the system be repaired? How accessible are repair parts? For Laval systems, as we've covered earlier on in the presentation, we can repair most systems within 2 to 3 days of receiving them. We keep 95% of the repair parts needed in stock to repair these systems, and we have a full-time staff of 5 electronic technicians who do nothing but repair camera systems. As such, we're able to get systems in and out very, very quickly back into the hands of the customer to make sure that they are being used in the field. The next question I have customers evaluate is, how difficult is the software needed to operate these camera systems? Is there any software needed? Is there something that I'm going to need to convert my video format into something that'll play on my computer or that I can share with a prospective customer? All of Laval systems export in the most pervasive video formats, whether that be MP4 or AVI, meaning you can quickly put it into your computer, send it via the cloud, burn it to a DVD, or simply transfer it to another USB stick. We make sharing your survey footage as easy as possible. And then the last point I like customers to consider is, the cost of a camera system. The reality is, when you look at a camera system, they appear at first blush to be very, very expensive, and they are not inexpensive pieces of equipment. What we like to tell customers is, don't necessarily evaluate a camera system based on its initial acquisition cost. Think about it in the context of how often you're going to use the system, how often you're going to be able to charge for the use of that system, and you'll quickly realize that if you're using the system at every single opportunity, at every single job, and making it a line item as a part of your overall operation, the payback period for that camera system reduces dramatically. Anytime a pump is pulled, anytime there's an opportunity to investigate a borehole, the condition of a borehole, we advise use the camera, add it as a line item to the service charge, and you'll quickly see the payback period of that camera drop dramatically. Okay, now we're going to open the session up to questions. I know I've thrown a lot at all of you over the last few minutes. So if any of you have any questions, please feel free. We've got several people joining us via the web now. So if you have a specific question you'd like to ask in regards to the presentation, the floor is yours.
What type of maintenance is needed or required?
Great question. So typically these systems will last in excess of 10 years if they're well maintained and taken care of. In terms of preventative maintenance, one of the things, and we talked a great deal about this during the presentation, that we always recommend you do is a cable head repair kit. That's the section of cable where the camera and the cable physically connect. And as you use this camera system more often, that connection will become stretched and worn, and it will affect the performance of the camera system. You'll see the screen cut in and out. You'll see a loss of the overall video signal. In some cases, you may lose the downhole lights. There are a lot of things that are attributable to the cable head that appear as though they're a greater problem than they actually are. Again, we recommend replacing that, depending on the duty cycle of the camera, anywhere between every 12 to 16 to 18 months. We do sell a kit. It is field repairable. There's no need to send the camera back to the factory. You can perform the repair yourself. It takes about 2.5 hours to do in total, 30 minutes to solder the connection on, an additional 2 hours to allow the epoxy to dry and form that watertight seal. But after that period of time, you're back up and running. Other than that, we always recommend trying to protect the camera as best you can. There are companies out there that will use cases that are a bit more heavy duty. A rifle case, for instance, that's padded. Something like that can be a great advantage in terms of putting the camera away and protecting it in transport. But if you're following those steps, ensuring that the camera is well protected, changing your cable head on a frequent basis, you should see a very long lifespan of this camera, probably in excess of a decade. Are there any other questions?
What is the warranty on a camera system?
Great question. So repairs, we offer a 30-day repair on all of the components that were addressed during that maintenance event. On a new camera system, we offer a 365-day warranty on all of the major parts and components, as long as they're related to a manufacturing defect within that first year of ownership. Are there any other questions?
Yes. How long does it take to be repaired if damaged?
So a camera system that comes back to our factory can normally be repaired within 2 to 3 days. We have a staff of 5 full-time electronic technicians who do nothing but evaluate and repair cameras. And we also keep 95% of the repair parts needed to repair a camera on hand at any given time. We really do pride ourselves on ensuring that we can get cameras back into the field as quickly as possible, because we believe that a camera system that's here in our facility is not out in the field making you money. So we always put an emphasis on returning them as quickly as we can. Are there any other questions?
Yes. What if I don't need 1,000 feet of cable?
We get this question a lot, and we have a camera portfolio that spans as shallow as 350 feet and goes all the way down with our vehicle-based systems to 5,000 feet. So ideally, we do have a camera system that's going to suit your needs and suit your applications. We normally get this question in relation to the gap between about 500 to 1,000. Someone's looking at an SC500, but they really could have the added benefit and added value of having 1,000 feet of cable. And if you think back to the presentation when I talked about the article that was published in the Water Well Journal by Ed Butts, one of his key points was buy a system with 1,000 feet of cable. And my point was, it's not necessarily a mandate that you buy 1,000 feet, but it is a suggestion that you evaluate a camera system that has more cable than you think you need. One of the things that we frequently see operators do is underestimate how frequently they're going to use the camera and for how long. Ideally, if this system is well taken care of, you're going to have it for the next 10 years. And again, your use case is probably going to expand dramatically. So today you may only be evaluating holes that are 450 or 500 feet deep, but 7 years from now you may need that additional cable And ideally, this camera is a tool. It's a money-making tool for you. And so by having access to greater depths, you have the opportunity to go survey a significantly greater market of boreholes than you would if you did not have that additional cable. Again, if you evaluate all of the individual component parts of a borehole camera system, the cable is really the least expensive part of the entire collection. And so we always evaluate a camera system really based on what am I going to need in the future, not just today. And so with that in mind, our suggestion is always buy more cable than you think you need. There's also some significant advantages with the RCam over the SC in regards to not only the amount of cable, but the powered winch, the solid state DVR, and the dual view camera. And again, remember, if you only need a down view camera, we do have the SC166. It is cross compatible with the RCam. So you can get that additional cable and not necessarily be limited from using a small diameter camera in a tight application. I'd like to thank you again for taking the time to view this presentation. In conclusion, Laval Underground Surveys is the company that pioneered the borehole camera industry in 1946. With each successive decade, we have continued to push the industry forward by introducing new and exciting technologies. We've coupled this innovative spirit with the practice of the Laval Difference, a call to action that focuses on placing the customer experience at the forefront of everything we do.